Hello, this is Dave Ferris, and I'm going to walk you through the rubrics and scoring for question 3 on the 2022 AP Stats exam. And just a quick overview, question 3 is going to be typically probability and sampling distributions. That will be for the foreseeable future. So anything on question 3 that you see is probably going to be in the world of either normal models, binomials, probability calculations of some sort, and some explaining and work, obviously, for calculations. And so that's the case this past year. Just a quick overview, every free response problem has parts, and the parts are labeled with letters. So every part of an AP exam is going to be scored as an essentially correct, partially correct, or incorrect response. Essentially correct means all the essentials are there. It may not be perfect like you would like in your classroom, but all the essential ingredients are there. And the rubrics and the checklists that I'll walk through will tell us whether they meet that criteria. Partially correct usually means there's a major thing omitted or something major that was wrong. Incorrect, typically there's 2 or more things that are majorly wrong or omitted from the answer. And so every part will get an E, P, or I. No numbers here at the beginning. You'll notice part B this year had 2 subparts, but again, because it's just one part, these 2 subparts are going to be scored kind of together. And overall then, part B is going to get, again, either an E, P, or I. And then part C, which is again a standalone part, will be either an E, P, or I. So when you're finished, at the end of the problem, every problem then finally gets a number. And so as you can imagine, a student that gets 3 E's, that's automatically a 4. If there's a P in there somewhere and then everything else is okay, then that's usually a 3. If they have an E and 2 P's and lots of other combinations, like even 3 P's, would give students a 2. There's lots of combinations that earn a 2. And then if there's just 1 essentially or 2 partials and nothing else, then that usually is a 1. And then anything that's just 1 partial or less would be deemed a 0. And on the real exam, when you grade it, if there's nothing at all on the paper, that's not even given a number. It's just given a designation of blank. And so it does not go into a student's, it goes into the student's score as a 0, obviously, but it does not calculate toward averages globally. So that's an overview of how we do it. And so most of the time when you're grading, you're really just looking for essentially correct, partially correct, incorrect at every part. And so I'm going to walk you through kind of a checklist system for scoring number 3, and hopefully it will make sense for you. And I think what would be a good idea is maybe to start with an example student's paper. And you can get these online to College Board website. They always give you 3 student samples. One is a student that got a 4, another one's a 3, another one's a 2. So you can get some good examples of not so good answers, and they're pretty common mistakes that students have made. Those are the ones they choose. So I'm looking at a student to start with that has everything they need. So let's look at the things that students have to have for full credit. So in the first part, there are 3 things that students must have to get full credit. So the first thing, they have to communicate clearly what distribution is being used and the parameters of that distribution. So for part A, this was a normal distribution problem, and so clearly there has to be communication that this is a normal distribution, and they have to include the parameters, and they have to be clearly marked in some way, clear communication, that they are dealing with a mean of 0.6, I believe, and a standard deviation of 0.04. So that's what we're looking for. So if you scan this student's paper, do they have clearly communicated a normal distribution, and do they have the mean and standard deviation? Well, it turns out this student has multiple places where they earn this credit. So if we can imagine, these are actually different students, because some students will just do a picture, or they'll do a formula, or they'll do words, or they'll do, something else. So this student has many, many layers. So first of all, they would get full credit for a normal model and the parameters simply by this standard notation. A capital N parentheses 0.6 comma 0.04, that is standard notation for a normal distribution with a mean of 0.6, standard deviation of 0.04. So any student that just had that would have automatically gotten credit for the first part. But it's there other places. Even when they have a z, and that's important, they would have to have the z there, followed by a formula with 3 numbers in there, well, you can assume, students can assume that a stats teacher or professor is grading this, and so when they write that, we know as teachers that 0.6 is the mean and 0.04 is the standard deviation. And so z has the connotation of a normal distribution, and then they've got the mean and standard deviation there. So that would have by itself been credit for the first part as well. So the students have it here a couple places, and they would get full credit for part 1. The second part to get full credit is they have to have clearly communicated the boundary of this calculation and the direction of the calculation, either greater than or less than or possibly even not equal to. Well, again, this student has it several places. First of all, they've got a picture of the boundary and the direction. That alone would have given them credit for part 2. They also said in symbols that they're looking for the probability that A, which was defined in the problem, they didn't make this up, that's the defined variable, A is less than 0.05, that would have given them boundary and direction. They also have the z-score less than negative 2.5. That would give them boundary and direction. So they have it here a couple places. Clearly they've got the second piece that they need for full credit. And then lastly, of course, they need the correct answer. And they have that. They have the correct answer written. So the 0.0062. So this student would have received an E for this problem because they had distribution and parameters clearly, boundary and direction clearly, and the correct answer. So that part is an E. Moving on to part B. Part B has 2 subparts, so you might imagine there's actually 4 components for students getting full credit here. The first one, and this is where it gets a little more complicated. They seem to get a little more complicated as you go down. But the first thing they have to communicate is they have to define the random variable of interest. And what's interesting to me is that exact phrase was on the 2021 exam. So 2 years in a row, students were asked to define a random variable of interest. This time, and you have to read the story because it's a little confusing, but this time, random variable X is the number of bottles in a box, and the box has 10, so it's the number of bottles out of 10. And so students had to communicate clearly that it's the number of bottles out of 10. And so what I'm going to write down is it's the number of bottles. First of all, it's not a percent or a mean or anything, it's the count or the number of bottles. And what's important on this piece is they had to state that it was out of 10. Because there's also a crate in this story, and some students reported that it's the number of bottles in a crate or something like that. But the random variable is actually out of 10. And that's important because in the binomial calculation coming up, n has to be 10. So that 10 has to be in there. That's an important thing to look for because there are some students that just said number of bottles in a box. That will not give them full credit for that piece. They have to say out of 10. So that's the first piece to get full credit. The second piece is they have to state, it says how that random variable is distributed, how it's distributed. Well, that's a little bit like the previous question when they said normal and mean and standard deviation. It's the same kind of question, but this time it's not normal. It would be a binomial because we have a probability of each bottle being underfilled. So they needed to say that it was a binomial and they had to have the parameters. The parameters would be n is 10 and the probability is 0.0062. And they've got that. So this student said binomial and they clearly labeled that n was 10 and p was 0.0062. So this student got the definition correctly, number of bottles in 10 that are underfilled, and they've got the distribution clearly named, even though it's abbreviated, and they've got the parameters there. So far they're 2 out of 4. There's 2 more pieces they have to have. Anytime there's a calculation being computed, there has to be work. And so step 3 is the work. But it's interesting because there's so much detail in part 2. You know, they've got 10 and 0.0062 in there, that all they're looking for the work is where the final answer, which is 0.0017, where that came from. So if we could even kind of skip ahead. Obviously, the correct answer is the 4th piece here. So the correct answer is 0.0017. So now if we look at where that came from, all they really have to communicate is what part of that binomial distribution did they add up, or did they pick out. And so again, this student has it multiple places. So you have to realize most students don't have 3 or 4 versions of the same credit. So had this student only said the probability of x greater than or equal to 2, they would have gotten credit. If they would have said that's the same as 1 minus the probability of 1 or less, that would have given them full credit for work. What else do they have here? If they would have said, I mean, look at all these different layers. That's another version of the same thing. That would have given them credit for work. And then, of course, here's the one that probably most students did, as I recall. They actually did the calculator version. And the calculator version is fine, although when they do the calculator version, they must label the inputs. That's the thing that's important. Calculations are fine typically on the AP exam as long as parameters are labeled. So all of these pieces that I just boxed in, so what are there, 4? All 4 of these by themselves would have given students credit for the work piece. So notice that this particular piece doesn't have to have a whole lot. They just have to communicate what parts of that distribution did they use or did they add up. In this case, it's 2 calculations, the probability of 0 and the probability of 1. But that can be communicated lots of different ways. In fact, they can communicate that with words as well. So a lot of these things that we've been circling, if students just described them in words, that would have been enough. So they got all 4 parts. They've got, I mean, pick which one you like. They've got the work thing going on there several places, and they've got the correct answer. So overall, that is an E. And then we go to the 3rd part, and they were supposed to calculate using like an adjusted, some adjusted numbers that they were given, and they were supposed to decide if the old programming is better or if the new programming, the adjusted programming, is better. And so there's only 2 things. They only have to have 2 things here to get full credit. The first one is they have to make the right choice. And the correct choice is to keep the old one. And so they had to make a choice correctly, of course. Choice correctly, and then they had to give a reason. It says, provide a statistical justification for your choice. Well, that sounds a little deep, but all they really had to do is calculate the adjusted, which was 0.023, calculate the adjusted, and then they had to compare it. And this was the part that a lot of students didn't do. This is one of those nuances in communication that I harp on, and you probably harp on, is that anytime you're making a choice between 2 things, you must actually compare them. You must talk about both of them. You must use a comparative language. And so what we would be looking for is, okay, they've got the right calculation, which is 0.023. Or by the way, you know, if they used empirical rule, they could say 2.5%. Because the standard deviation is -2, or the z-score is -2. So they could do empirical rule. So as long as it's, you know, that 2.3 or 2.5%, that's going to be counted correct. So did they actually state that we're picking the old one or the original because of there's a higher probability with this new one of having underfilled. And so they did. They have it right here in the last sentence. If they retain the original programming, there is a lesser chance. There's the word that got them credit. So the second piece of this part is to actually compare. Actually compare, and that is something that you have to watch for. A common thing is for them to say, well, the old was what was the old? 0.0017, or no, 0.0062, that was the original, and the new one is 0.023. Well, that's not comparing. Just stating that one is this number and the other one is this other number, just stating the two numbers does not get the comparison credit. And they have to say, and, this is higher, or and this is lower, or this is better kind of thing. So they have to make a very explicit comparison of the two numbers. They can't just state the two numbers and then have the grader figure out why they chose that conclusion. So those two pieces, choose correctly, that the old is better or the original is better. And then the second component actually has two pieces. There has to be a calculation of the new or the adjusted, and there has to be a comparison that leads to that conclusion of choosing the original. So there you go. That's what we're looking for. So there is a checklist. I would suggest you make one out that's a little, maybe a little bigger, a little easier to read, because I'm just putting these in the margins. One thing I will mention too about these things that they have to have, particularly the, let's see if I can maybe highlight this. So let's start with this distribution parameters thing. Any of these where you've got multiple ways that students can depict them, they really can. They can have a graph, they can have calculator notation, words, standard notation. There's lots of ways that some of these can be communicated. So as long as a teacher of statistics, as long as it's clear to you, whether it's words or a graph or calculator notation, that's what we're looking for. We're looking for those things in one of those forms. And that's what made this one a little tricky to grade, because there's so many different ways students can communicate. One thing I do remember too, with the, see if I can highlight this. You saw the student made the drawing over here. Let's say we were looking for model and parameters with that diagram. Well, that curve looks like a normal, so we'd give them normal. And the mean is in the middle, 0.6. The thing that would be missing here, though, is they don't have the standard deviation. So if this is all students had for the model or the distribution and the parameters, we could not give them full credit because the standard deviation is not there. But we would go looking. It's like, all right, so it's not here. The standard deviation is not here. But is it somewhere else? Do I see the standard deviation someplace where it's clearly communicated? And of course, in this student's case, yes, the standard deviation is in the denominator right there, and so we would give them credit for that. It's also in this standard notation. So sometimes you do have to go looking for the answers someplace else. One other thing that came up with part B, speaking of looking for things, when they defined the random variable, the 10 had to be with that definition. So the 10 had to be there. You can't go looking and say, oh, well, they put 10 down here, and so that's going to count. No, it won't count for the definition. However, let's say down here, somehow they forgot to say that n was 10, and that's one of the parameters. Well, they did say 10 up here. So what's interesting is they could get the credit for n equals 10 had they forgotten it, and let's say that's the only thing that they forgot. You could pop up here and say, well, they know that n is 10. Now, of course, they don't just have to have 10. They've got to have the probability, and they've got to have the x as well. So in that odd case that maybe the only thing a student forgot down here was that n was 10, well, you can look up here, and if they had it up here, they can receive that credit. But again, just to be clear, in the definition, the 10 has to be there. You cannot go down here and say, oh, they know it's 10. Up here in the definition, 10 has to be part of the definition. It does get a little complicated. Hopefully that's not too much information. All right, now let's take a look at some not so perfect answers. Now, best practice, if you've got the discipline to do this, best practice would be to push pause right now. I will tell you that sample 3B is a 3. That means on one part, A, B, or C, students were missing something that was important, or they said something wrong that was important, but just maybe one or possibly two little dinky things. So why don't you do that? Why don't you push pause? Why don't you read these three, practice your checklist, 3 things for part A, 4 things for part B, and 2 things for part C, and see if you can find the problem. Congratulations for those of you that could do that, have the discipline to do that. So on part A, let's see if we can go through the checklist. First of all, we're looking for the distribution and the parameters. So when you see the word normal, that right there is enough, or of course there's a picture, so it's there twice. And then we're looking for the mean and standard deviation. Boy, don't you love that when a student just says it exactly, explicitly, there's the mean, there's the standard deviation, nicely done. But just an aside, if you look at the numbers there, they do have the mean labeled here. And then when they've got these little increments here, if you can do the math and figure out that they're going out 0.04, 0.04, 0.04, that actually can get them credit for the mean and standard deviation too. So they actually have it twice. And so they get the first check mark for distribution and parameters. Now we're looking for boundary and direction. Well, it's hard to read the boundary there, but I think it's here, if you can decipher that. But even if it wasn't, they have the lower and the upper labeled in the calculator notation, so that would also have given them the full credit. And then they've got the answer out to an amazingly large number of decimals, so they've got the third part. So this student got an E for part A. Part B is where we have a problem, or actually 2 problems. They say the random variable of interest is the probability. Well, no. The random variable of interest is the number of underfilled bottles in a box of 10. So they automatically miss the definition. And then they said it's distributed not binomially, but normally. And so they don't get the second piece, which is the, how's it distributed? They did not get that. Now, interestingly, they can still get partial credit here because if they get part 3 and part 4, they can still recover a P. And they did get the right answer. If you look down here, sometimes I like to go out of order just to see if I even need to look for anything. So they did get the right answer. Now I have to just see, did they have the right work? Well, remember, the work just really can be symbolic. So that would have gotten them credit. Here's another equally good way of doing that. And then notice that there's even a calculator version, because again, if you're a calculus or a stats teacher, you know what binomial CDF means, and they've got N and P and X labeled. And so that's actually the correct calculation for 0 and 1, and then they took 1 minus that. And so all that's 3 ways. They've got it there 3 different ways. So they don't get extra credit for that, but they do get credit. And so 2 out of 4 on this, according to the rubrics, is still a P. So right now they're sitting at an E and a P, and they can still get a 3 overall, and they do. Let's see how they did that. You have to read quite a bit on this student's answer. They remind you that the original probability was low at 0.0017. And then they say something about adjusting would only increase the likelihood of underfilled. Ooh, they got the comparison. Now we just have to look for, did they calculate the adjusted probability? And they do. There's the 0.023 number. And so they got all 3 parts, or all 2 parts. It's actually 3, I guess. So they've got the decision. I didn't really circle that. They should use the original programming. So they've got the decision. And then they've got the calculation of the new probability, and they've got the reasoning. They said increase. And so they did get an E for this. So overall, this student got an E, a P, and an E, and that translates to a 3. And that's still a really, really good score. Moving ahead to the third sample. Again, best practice would suggest that you pause, and this student got a 2 overall. So you're going to find multiple things that are wrong or omitted from this one. And I'll give you a little hint. The problems are all in Part A and Part B. Part C is actually fine. So why don't you take a couple minutes to see if you can score this correctly. All right, welcome back. Let's see what happened here. So the first thing on our checklist is model and parameters. And so we can see a normal picture. And so we would give them credit for the normal thing. And then you can see the mean. It's a little hard to see if that's a 0.6. Seems like that would be a 0.6. But now we're looking for standard deviation somewhere else. Well, they've got it over here. Standard deviation of 0.04, but then there's a couple things that are bothersome, and not just bothersome, but they're one's wrong and one is just necessary. So one of the things that you'll notice here is that they've got X bar labeled as 0.6, and that's just not right. The sample mean is not 0.6. That's the true percentage of underfilled bottles that they're aiming for, and so that should have been mu, and that's just the wrong label. And so that would have, by itself, given them a ding. The other thing that is kind of unrecoverable is, a lot of times we're looking for the mean in the formula. And so typically that's going to be a mean that we're looking for. The problem is their labeling. You notice they talk about a z-test, which is kind of interesting. And then they do say the probability the shampoo will be underfilled, but they're saying the probability is equal to the z-score. And then somehow there's an arrow that turns it into a probability. So they don't ever really say that this is a z-score. Had they said it was a z-score, then we might have been able to give them credit for the mean. But then this thing about X bar was just wrong. So thankfully, we didn't have to kind of make that call. That's definitely not getting the parameters credit. The boundary and direction, I think we're good. We've got a picture of that over here. And so that takes care of that. And then they actually did get the right answer. So they did get 2 out of the 3 components, so they got a partial. In Part B, we have some multiple issues. They said the random variable of interest is the amount of underfilled bottles in a box, but there's no 10. They didn't say 10 bottles, and so they can't get credit for that first component of definition, because they did have to say that a box is, or they had to say 10 bottles in a box, and they did not. And then the how it's distributed, they said the variable is randomly distributed instead of binomially distributed, so they can't get credit for the type of distribution. They can still get a P, so we keep looking. So remember, the work has to be there for the answer, and we don't see either one of those. I don't see anything there that would suggest that they even have the right work or the right answer. So they really got nothing out of this. There's really nothing here, because the 0.0062 was the answer to the previous question. This was supposed to be like 0.117% or 0.0017. So this student got an EPI overall. No, not an EPI. They got a PI so far. And then Part C, I already told you they got all this, but let's just make sure. They've got the calculation, which doesn't have to have work. I can't remember if I said that or not, but the calculation in Part C does not really have to have work. It just has to be there. So they've got the right answer. They recommended the original programming, so they got the decision. They've got the right answer. And then did they say something about it's because this would increase the likelihood of underfilling? Yes. They got the comparison and the reasoning for that. So this student got an E for Part 3. So overall, it was a PI. And a PIE translates to a 2. And I did not look this up, but usually the average score globally on the free response is 1 point something. So a 2 is still above average. I tell my students that that's actually not too bad, especially for a probability question. Those tend to be low scoring. So there you go. That's a quick run through. Of course, the rubrics that are published have more detail than I gave you, and they have some what if scenarios. Those are always good to look at. There's some interesting what if things that come up that you can find in there too. Not everything, unfortunately, is in there, so sometimes you'll have to just make some good professional judgment, and don't be afraid to do that too. So there you go.